session. In this session, we will be again talking about the progression. Let me quickly give you the review of what we discussed in the previous video. We discussed the arithmetic progression in detail. We understood that arithmetic progression is the series of numbers in which the terms are equally spaced. That means where the difference between the two consecutive terms remains constant. Here, there were two things that we learned. First, finding out the nth term of the arithmetic progression. For example, if the first term is a, the second term is a plus d, where d is the common difference and a is the first term, which is represented here. Then the nth term of the series can be represented by a plus n minus 1 into d. It's not a formula, it's a very common sense that you can use. That in third term we have 2d, in fourth term we have 3d, so in nth term we will have n minus 1d. Now, the important part is to understand how to find the sum of the n terms in AP. So I just took an example 1, 3, 5, 7, 9, 11, 13, 15, 17, and then I just showed you that in any arithmetic progression, one thing to observe is that the sum of the first and the last term remains to be the same as sum of the second and second last term, which is equal to the third and third last term sum, fourth and fourth last, and so on. So if there are n terms in the series that we have to add, then such pairs that we can get is always equal to n by 2, because if we have 9 pairs, then we have if we have 9 terms, then we have 9 by 2 pairs, 4.5 pairs. If we have 10 terms, we will have 5 pairs. So for n terms, there will be n by 2 pairs, and every pair gives you the sum that is equal to the sum of the first term and the last term. This becomes one of the most important thing about the arithmetic progression, which we consistently have been using in some official GMAT questions. If we turn these things into the formula, that means if you write the first term as a and the last term as a plus n minus 1 into d, then the same sum of n terms becomes n by 2 twice of a plus n minus 1 into d. In the previous video, we did not discuss any question. So here we will discuss a question. And before we get into the discussion of that question, there is also one very important observation of this arithmetic progression, which you can see on the screen now. It's an important observation because it has been repetitively used in the questions of number properties, in the questions of series, and in the questions of statistics as well. If you have any arithmetic progression, then whether you calculate the mean or the median or the average of the first and last term, you always see that all these three things are always equal. So the concept that I want to communicate is simply that in any arithmetic progression, the mean is equal to the median, and that is equal to the average of the first and the last term. It's very important, as I've already told you, and you can already observe it in one of the arithmetic progression. I've given an example. Now in the next couple of videos, we will also see how to make use of this concept. Now let me take you to the question that we wish to discuss quickly. So the question that we have here is right here. What is the sum of the even integers between 200 and 400 inclusive? So technically we have to add all the even numbers, that is 200 plus 202 plus 204 and so on till 400. So to answer this question, we already know what is the sum of an arithmetic progression, but even to plug those things in, we need to find out how many terms does the series have. So although you can see the solution here, I would like to explain one thing very quickly, how to find the number of terms. Now there are several formulas devised, but as my general tendency is, I try to stay away from the formulas as much as possible. So I would quickly discuss how logically you can find out how many terms does the series have. So see, we have this series, and if you quickly think of how many terms do we have from 201 to 400, how many consecutive integers we have, then the total consecutive integers from 201 to 400 will be 200. And out of those 200, half of them will be even and half of them will be odd. So there are 100 even numbers. And since the series starts from 200, therefore there is one more term that we need to include in the series. So here for the given series, the total number of terms that we have becomes 100 plus 1, that is 101. Now there are two ways you can try this out. First, using the formula, which is n by 2 twice of a plus n minus 1 into d. Second, using the principle that sum of the n terms is n by 2 first term plus last term. So by the first method, we have plugged in 101 as the value of n, a is 200 and d is 2. On the other hand, we have done simply 101 by 2, these many pairs, and every pair is equal to sum of 200 and 400. That gives us the answer. So this is how I solve this question. That is why I have checked it. It's one of the best ways of solving such questions in which we have to find out the sum of the arithmetic progression. And I think I'll stop this video here, and in the next video we will discuss more questions on the similar lines about arithmetic progression. Thank you so much for watching it.